So hi Apurva, how are you?
I'm good.
Yeah. I have seen your profile, so looks pretty impressive. So Apurva, can you let me know how much experience do you hold in big data?
I have near about 1.5 year of experience in big data.
Okay,
So when I
and
say
that's
big data, it also includes, uh, big data technologies as well as Java. Java with Spring Boot.
understood. So you have worked on multiple technologies, not just only on big data. That's what you are saying.
Yeah.
Okay. And in big data, what all technologies have you worked on?
Uh, in big data, I have worked on Spark, Hive, and Kafka.
Okay, that's great. And what kind of work you have done with these technologies? I mean, is it something a new development or just changing some of the existing things?
Uh, at Java side, there was a new development like creating microservices. Developing microservices from scratch. But
Mhm.
at Spark side, I haven't done development from scratch. I was working on uh, production issues or internal uh, bugs and all. So
Okay. So
for
what kind of
ETL,
production issues, I mean, normally you have dealt with in Spark?
uh, actually the domain I was working on was the retail domain. So we were
Okay.
getting uh, retailers and vendors data in the form of files. So let's say uh, I I have to remove the headers and footers in the file. So uh, let's say I'm removing that using Spark. We can pre-process the data using Spark, right? So what was happening? The bug I was fixing was uh, when I was taking like rdd dot tech or rdd dot limit. Let's say I have configured in my UI that these many are my header records. But what was
Mhm.
happening was it was taking my limit was taking what was my expected answer was it should take first four or first five records from first partition, but limit was taking every time from other partition because
Okay.
what mistake I was doing, I was first applying some transformations and actions, and then I was retrieving records, which those transformations and actions were actually shuffling my data. So I was not getting top five records. So these kind of bugs I have resolved in production.
Okay, so why Spark? Why not you can do with this with shell scripting? I mean, the same thing, removing headers and footers, you can do with shell scripting also, right?
Yeah, self scripting. Yeah, but I haven't done such thing because the project I was working on was we have some microservices, and so that one of the microservice will submit the Spark job, and we were doing those extracting header footer and pre-processing or structuring the data into data frames. So that kind of work we were doing at Spark and at
So yeah, I understand that, Apuva, but my question is, I mean, you would have thought about if this could have been done using other technologies, like just a shell scripting. I mean, why you want to go with something as fancy as Spark? I mean, was there any particular reason, or it's just that you were told that you have to do it using Spark?
uh, yeah, when I before I joined the company, they were doing like this only. So I never asked them like how we are doing in Spark only. Why can't we
Okay.
go with self scripting? So I was just going with the flow.
Okay. Okay. So what is Apache Spark? Can you tell me what is a Spark and what are the advantages of it?
Yeah. So Spark is a distributed processing framework. I mean, if we have a very large amount of data, then we can then the data gets distributed across nodes, and we can process the data parallelly by sharing
Okay.
the load on each node. So before Spark is actually built on MapReduce framework of Hadoop. Before
Oh, is it?
Spark, uh,
So is
I mean the
Spark built on
background.
MapReduce framework?
I mean the background process is MapReduce, derived from MapReduce only, right?
Okay, that is something interesting. So you're saying Spark works on top of MapReduce. Okay. So then why not use MapReduce only then? If Spark is on top of MapReduce, then why not directly use MapReduce?
Spark, I mean MapReduce was taking lot much time for processing the data, and in Spark is the in-memory processing framework, so which is faster than MapReduce. Though the
No, but
background,
yeah, no. Yeah, go ahead.
though the background process is MapReduce only, but it processes the data in memory. In-memory processing is happening in Spark, so that's why it is fast.
Okay, fine. So it is in memory, that is why it is fast. So let me ask you one question. The processing is always done in memory. Have you ever thought of doing processing on disk? No. The data is always loaded in memory. Then why do we say Spark is in memory? Because it is true with any other computation. Computations never happen on disk. That is the fact. Then why do we use the word
Yes.
in memory with Spark? Any idea
I
on this?
think we Spark has some functionalities like cache and persist. So using those approaches, we can cache our intermediate results in memory rather than storing in disk, so that it can fetch as and when required. So that it makes computation faster.
Okay. So you are saying when we are not using cache and persist, then Spark is like MapReduce probably. Is that the correct understanding?
Uh, no, not every time it's no, not every time. Correct. It is faster than MapReduce.
Then what is the exact reason? Because MapReduce also processing happens in memory. Let me tell that. Because processing never happens on disk.
Mhm.
Yeah. So anyways, no issues. Let's proceed. What is RDD in Spark?
Uh, RDD is the long form is resilient distributed data set. It's a distributed distribution of data uh, across nodes. I mean, we cannot. It is a core abstraction of Spark, and we cannot modify it.
Why we cannot modify any reasons?
No, I don't have any reason for this.
Okay. Uh, Fine. So why do we say you said the long form of RDD is resilient distributed data set? What is the meaning of resilient here?
Resilient means immutable.
Resilient means immutable. No, immutable means immutable. I mean, resilient means it is resilient to failures, actually, right?
Oh,
Yeah.
okay.
So we say Spark is in memory, but even though it is in memory or RDD is in memory, it is resilient to failure. How come? I mean, because in memory the data can vanish, right? How is it resilient to failure even though it is in memory?
I think Spark internally creates uh, directed acyclic graph, and through which it can trace back the whatever transformations and actions we are applying. So uh, until an action is triggered, nothing has happened actually in RDD. So what it does is, using the directed acyclic graph, it can trace back the uh, from where it was started. So how this is resilient to failure, I think.
Okay, okay, fair enough. Fine. Now, to write Spark code, which language have you used?
Uh, Actually, I was working with Scala with Spark.
Any reasons why Scala was the preferred choice for you?
It was not my choice, but I have heard from the team lead and manager that I know the concept, like Spark was written in Scala. So I have heard that Spark gives better performance with Scala because it is written in Scala, and not gives that much better performance with Python.
Okay, okay, fine, fine. That's good. Okay, so what is the difference between reduce and reduce by key in Spark?
Reduce is an action, while reduce by key is a transformation, and reduce by key uh, generally performs with key value pair RD.
Okay, now let me ask you one follow-up question. Why do you feel the Spark developers have given reduce as an action and reduce by key as transformation? What can be the reason behind it? There should be some reason, or just like that. I mean, as per your thinking, you can let me know. Why do you feel reduce is given as action and reduce by key is given as transformation?
No, I can't answer this question.
Okay, okay, no worries. Fine, Apurva. Let us proceed. So, do you know the difference between repartition and coalesce?
Yeah,
Yeah.
repartitioning uh, we do generally to increase the partition, while coalesce we do to reduce the partition.
Okay. So, can't repartition be used to decrease the partitions?
By default, the number of partitions are 16, right, in RDD or in RDD. So let's say my default partitions are 16, then I
No,
can't
just a second.
reduce.
So, just a second. Let's say I have a 1 GB file in HDFS and I am creating a RDD on top of it. How many partitions will my RDD have?
16.
How come 16? I didn't get that number.
The default partition for an RDD is 16.
Okay. Then even if you have a 1 terabyte file, we have 16 partitions, you are saying?
Uh, yes.
Okay. Let's say you have a 1,000 node cluster, then by default, why 16? I mean, partitions. I actually have never heard of this concept, 16 partitions. So that's why I'm very curious to know.
So you are saying if we have 100 node cluster,
1,000 node cluster, and we have 1 terabyte file. Then how is the behavior? How many partitions will be there for RDD?
uh, I have read it somewhere that the default number of partitions is 16. So by default, it will create first 16 partitions, and as per our need, uh, we will distribute it further along the node.
Okay, okay. Consider you have 16 partitions and you want to make it 8. Can I use repartition for this?
No, we have to use coalesce in such case, and if we want to increase than 16 partitions, then we can use repartition.
So you are saying from 16 to 8, if I am trying to do with repartition, it will fail. That's what you mean to say?
Yeah, yeah.
Okay, fine, fair enough. Now, what is the difference between narrow transformation versus a wide transformation in Spark?
No, I haven't heard of such concept.
Okay,
Narrow and wide.
okay, no worries. What is the difference between cache and persist?
Cache, I mean, we can, if we apply cache method on RDD, then by default it gets stored in
It will store. It will get stored where?
it will get stored in memory. The data will
So,
be cached
so
in memory.
okay, the RDD was already in memory, right? Isn't it?
Yeah, but using cache, say we can store intermediate results. Let's say I have applied a couple of transformations on my RDD and I want to store that intermediate results so that uh, I can use it multiple times in future. That
The
cached
intermediate
RDD.
result was a RDD only, right, Apurva? I mean, let's say from RDD3 we created RDD4 and we are trying to cache RDD4. But RDD4 was already in memory, right? RDDs are in memory. Then why was there a need to cache it?
But see, let's say we have performed some transformations, but we know that nothing has happened till now because we have performed only transformations, and until we triggered an action, then the actual execution starts. So that's why we need cache and persist to store such intermediate results.
Okay, that is fine. What is the difference between group by key versus reduced by key?
Group by key will only give me I mean give it will not be used for aggregation operations, while reduced by key used for aggregation operations.
Oh, group by key is not used for aggregation.
I mean, reduce by key we can do aggregation operation with just one function, reduce by key. But with group by key, I have to first group. I have to apply group by key, then some aggregation operation on top of it. So it is two-step or more than two-step process. But reduce by key is just one
Apart
step
from
process
steps, is
for
there
doing
any difference?
aggregation.
I mean, it's okay if I write little bit more code. That's fine. But is there any other difference or otherwise both are same? I hope you got my question right. So what I am saying,
Yeah, yeah,
you
yeah.
said for group by key, one additional line is required. That's okay. I'm okay to write that.
Mm-hmm.
So apart from
Mm-hmm.
that, is reduced by key and group by key same or there are other differences also?
I think they are same.
Okay, understood. Uh, so when you worked on Spark, how do you track the job? I mean, whether the job is performing well or not. How do you track it?
Uh, when we submit a Spark job, a job gets submitted in the yarn cluster. So
Correct.
there we can see its progress. If I see in log inside log it's the job is succeeded, then I can say the Spark job has been completed.
Okay, so you have ever seen the Spark UI where we try to see the DAG and all?
Yeah.
Okay, so when you have seen the Spark UI, you might have seen for a job sometimes multiple stages are created. What are those stages? Why multiple stages get created?
Uh, because inside on every worker node there are multiple executors. So for each executors, so our Spark cluster assigns some assigns uh, launches executors, and inside executors we have different tasks, so that so my each task gets split into stages uh, according to my number of transformations and actions.
So how
So that's
exactly it
why
is
we
split into multiple? Let's say if I have three stages, how exactly I am getting three stages? Or it depends on system, any number of stages it can create.
uh, it depends on the uh, number of operations as well as the number of the amount of data we have.
Let's say I am calling 100 transformations. Map, filter, reduce by key, reduce, lot of transformations I am calling. Then 100 transformations in total. How many stages will I go?
Um, no, there will not be 100. There will not be 100 stages.
Okay.
Uh, I think it depends on number of map number of mappers or reducers. No,
Okay.
I'm
Okay.
not able to answer this question.
Okay. So what all Spark optimization techniques you have used in your projects?
Optimization technique. Uh, Using broadcast variables so that we can balance the load across various clusters, and
Uh, just a
using
second. So when you say broadcast variable, how does that give you benefit?
let's say I have to perform join uh, on one table, and that join has to be happen in for every partition data. So what I will be doing is instead of writing it again and instead of reading it again and again, I will broadcast the whole broadcast the whole data set across clusters so that it can read. I mean, this is how
Okay.
we will optimize the code. And
Okay.
also cache, and if I'm not wrong, cache and persist are also the optimization technique.
Okay. Uh-huh. Any other things?
No.
Okay, let's say you have two tables. Each table is of 1 TB, right? Two tables, table one and table two. Table one is of 1 TB, table two is of 1 TB. Uh,
Mhm.
can you still use broadcast join?
No,
Why?
because broadcasting this huge amount of data will not be feasible.
Okay. Any reasons why it won't be feasible? Because anyways, across the cluster,
Uh,
we are storing huge amounts of data, right? So why broadcasting huge amount of data like 1 terabyte is not feasible?
because see, even if we broadcast the data uh, across every node, we have to read it again, right? So it will consume a lot of time in reading that much of data again and again. So if we have small amount of data which is to be used across clusters, then only we can go for broadcast.
Okay, okay, understood, understood. Fine, I understood. Why Spark is lazy, Apurva? Why do you feel Spark is lazy? Any reasons or any benefits do you see based on that?
If the um, benefits I don't know, but what is lazy evaluation I can tell, but I don't. I mean I don't know the benefits.
Okay, okay. No worries. Yeah, understood, understood. So I think Apurva, I mean, we are kind of done with this, right? And
Mhm.
it was really nice talking to you, Apurva. Thank you so much, right, for attending this interview. And definitely we'll get back to you with the results of this. Thanks a lot, Apurva.